Okay, hi there. So yesterday I did a video that involved this question, but I got cut off right near the end. So I'm going to do this as a separate question. So number 3 asks us, in the above example, rank the salts in which PbI2 is least soluble to most soluble. So that would mean if you had some PbI2 and you're putting it in, which of the beakers would basically allow the least amount of PbI2 to dissociate, all the way up to which would be cause the most PbI2 to dissociate. So if we go back to the question above, we talked about this the other day. We saw that there were two chemicals that decreased the solubility. That was Ki and MgI2. The NaNO3 had no effect on the solubility of the PbI2, and the other two chemicals actually increased its solubility from sodium sulfate and potassium carbonate. Okay, so to be, I guess, least soluble would be something that decreases the solubility. So if you look at the first two examples there, the Ki and the MgI2, I guess the first thing we'd want to know is the equilibrium reaction for PbI2 would be an equilibrium between the solid state and its ions, so Pb2 plus, and the iodide ions. And the Ksp for this would be equal to the concentration of lead ions multiplied by the concentration of the iodide ions, and we have to square that. So now if we look at the first example, Ki, the concentration of the iodide would be equal to 0.1 molar. But the concentration of the iodide from the magnesium iodide would actually be 0.2 molar. And that's because for every 1 MgI2, you actually get 2 I's. So you're doubling up on the concentration. So the MgI2 actually has more iodide ions in solution before you add the PbI2. So going back to the equilibrium, that chemical would have more of the iodide there already before you add the PbI2. So that would have a bigger impact on the solubility of that salt. So really MgI2 would be the compound that has the biggest effect on making PbI2 least soluble, and then the Ki, potassium iodide, and then next would be the sodium nitrate, and then clearly the next two would be the last two chemicals, which actually increase the solubility of the compound. Now, the concentration of the anions that precipitate the lead are both -2 charged, so the sulfate and the carbonate. So their concentrations would both be 0.1 molar. So it can't be about concentration of those ions in solution has the impact. But what we could look at is the Ksp for those two compounds. Now we're told that the Ksp for lead carbonate is 1.5 times 10 to the minus 13. That's for the lead carbonate. That's quite low. And the Ksp for the lead sulfate, I have it written down here, is 1.8 times 10 to the minus 8. Now you can get that from the data booklet, and that would be for lead sulfate formation. And so the Ksp formula for this would be Pb2 plus and carbonate. And this would be the concentration of the lead 2 plus times the sulfate. Now both the anion concentrations we said were 0.1 molar from the question above. And so we can see that in order for this to give us a number of purple's nice, 1.8 times 10 to the minus 8, and this would be 1.5 times 10 to the minus 13, that the most lead we could sustain for this one would be 1.5 times 10 to the minus 13 divided by 0.1, which would give us 1.5 times 10 to the minus 12. And here, the concentration of the lead here would be equal to 1.8 times 10 to the minus 7 molar. So we can see that the first substance here, the minus 12 one, means we'd have much less lead possible in there. So that would be the one it's least soluble in. And the second one has a slightly higher number here, 1.8 times 10 to the minus 7 molar lead possible. And so that would be more soluble. So if we're going from least soluble to most soluble, pause. Okay, I'm going to just restate that again. Sorry, I think I might have said that backwards. So the lead concentration possible in the one that has the carbonate, is 1.5 times 10 to the minus 12. So that's this number here. And so what that would mean is that as we're adding the lead iodide, the lead ions would be being removed as that's occurring, as would be the case for the other compound here. But because the number for the first one is so much smaller than the one for the next one, it means that more lead ions would be removed from solution as the lead iodide is being added, which means that there would be a greater extent of the chemical being dissociated that way. So if we're moving from least soluble to most soluble, then the solution containing the sulfates would come next them. And so that would be our, where is it here again? Sorry. Sulfate is the sodium sulfate. I'm having lots of problems here. Sodium sulfate. And then the last one would be the potassium carbonate. So that would be the order from least soluble to most soluble for lead iodide.